Hey everyone, in this video we're going to cover preparatory support material for your Math 155 class, week number 9. Specifically here in this video we're going to look at multiplying lengths. We're going to have to do some conversions. I'll demonstrate how to do some conversions, converting from inches to feet, etc. And then we're going to look at evaluating expressions involving lengths. Pretty much that's going to be a review of your order of operations, if you will. All right, so let's just go ahead and get into it. It's not too much to this, but it can get a little, as they say, sticky if you let it. Not much to it, but you got to watch what you're doing. All right, so multiply, and it says if conversion is needed, convert to the larger unit of measure. Convert to the larger unit of measure. There really is no standard as to what you should convert to. So if you've got like we're here in this second example, we have inches and feet. Do you convert to the smaller unit of measure? Do you convert to the larger unit of measure? And it will really depend on what mathematical subject area you're in. Each tends to have its own preference. The majority like us to convert to the smaller unit of measure. But here in this case, we'll convert to the larger unit of measure. And I think we see what that means. We can see, hopefully most of us know that an inch is smaller than a foot. So the smaller unit of measure would be the inch. We'll convert to the foot. So that's the practice we'll follow here in this part of the presentation. It really doesn't matter. It's just whatever you're asked to do. As a rule, if you're not asked to do anything, there's a general rule. And if you're not asked to convert to any specific unit of measure, you have different units. Maybe you have ounces and pounds and tons, if you will. Those are all different ways to measure weights using our system of measures. If you're not told what to convert, a common practice is convert to the smaller unit. Okay, but here we're going to convert to the large. We don't care. We don't care which way. So here we've got our first problem. We've got 4 centimeters. Centimeters about the width of your thumbnail. Okay, about a ½ inch. You go into the doctor's office and they say, yeah, you've got a 6 centimeter slash that we need to put some stitches in. That's about a 3 inch. That's a bad cut. Okay, 4 centimeters times 12 centimeters times 5 centimeters. Multitude of ways to do this. Very simplistic way to do this is just deal with the numbers first. 4 times 12 times 5, and then we'll deal with the units of measure. We'll simply go centimeter times centimeter times centimeter. Okay, and if we go 4 times 12, we get 48, and then times 5. Okay, let's see, what's 5 times 48? Let's see, 5 times 40 is 200, 5 times 8 is 40, so 240. So 240, okay, and this is centimeter. You can look at that as 1 centimeter, and 2 centimeters, and 3 centimeters. It would become centimeter cubed. That would be the answer to this one, okay? So that is a way to do this one. This is perhaps, you can visualize this as maybe looking at a rectangular solid, or what maybe we call it a box. We've got our length, and we've got our width, and we've got our height. In reality, what we're measuring is the inside of this, which is called the volume. So the volume of this would be 240 cubic centimeters. In other words, if we had a box that was 1 centimeter by 1 centimeter by 1 centimeter by 1 centimeter, we're saying 240 of those would fit inside of that. Okay? Didn't really need to take it that far, but there's basically what that's showing us. So here on this second one, we're doing kind of the same thing, but we got to do some conversion first. We got to convert inches into feet because we're being told to convert to the larger unit of measure. Multitude of ways to do this as well. I'm going to show you a very simplistic way. Let's just do it over here on the right. I'm going to take 36 inches. I'm going to make it a fraction. We can make anything a fraction by putting it over 1. I'm going to multiply that, and here's the key. Here's one of the key things. Whatever my unit of measure is here, inches, it goes down here. And the unit of measure we're trying to convert to will always go up top. Okay, so that's how we set up our equation. And on the right side of this equation, there's going to be a 1. Okay, the 1 always goes with the larger unit of measure. So what's larger, an inch or a foot? Well, a foot is. Okay, so there's our 1. And then we ask ourselves the question, in 1 foot, how many inches are there? There are 12. Okay, we multiply straight across. The inches will have the effect of canceling each other out. 36 times 1 gives us 36 feet. Okay, 1 times 12 gives us 12. And then 36 divided by 12, because we know the fraction bar means divide, right? It always has, always will, and it's always top divided by bottom. 36 divided by 12 is 3. So this becomes 3 feet. Now we can solve this problem. We're going to use the same process that we used here. Let me slide this up just a little. Use the same process we had here. We're just going to deal with the numbers first. We're going to go 3 times 4. Oops, 14 for some reason. I'm doing it again. 4 times 3.3. Got 14 on my mind for some reason. Times feet, times feet, times feet, because we got everything in feet now. So let's just use the calculator here. So we got 3 times 4, we know is, of course, 12, times, let's see, what do we got here? 3.3, 3.3. Okay, so we have a solution of 39.6. And how many feet do we have? We have 3 of them, so feet cubed. Okay, so our final solution here would be 39.6 cubic feet, or feet cubed, whatever makes you happy. Okay. Again, that would be dealing with something that has 3 dimensions. That would give us the volume of something, if you will. The volume of a 3-dimensional shape is the inside capacity, whereas the outside, we will call that the surface area. Surface area. And surface area, you're really just getting the area of each one of those sides. A cube here has 6 sides. There's a front, there's a back, there's a top, there's a bottom, and there's 2 sides. There's 6 panels, if you will, that encompass a cube. And, you know, to get the surface area, we'd get the area of one of those, and basically, if they're all equal, multiply that times 6. Okay? All right, your 155 instructor will talk more about surface area. All righty. So here we're going to multiply, and you notice I've just put one problem on this one because we got a little bit of work to do. We're going to multiply, and if conversion is needed, as we've been told, convert to the larger unit of measure. Well, first off, we need to identify our units of measure. We have a mile, we have feet, and we have inches. So we have 3 different units of measure. Well, we need to convert them into a standard unit to get a final solution. Well, here we're being told that we're going to convert into the larger unit of measure. That's the guideline we were given at the beginning. We were told to do that. So there's something you have to know, and this is something you can look up in the appendix of your 155 ebook, or you can simply Google it. You know, we've got to know, for example, here how many feet there are in 1 mile. Okay, if we're going to convert this to miles, a mile. You know, and basically we know this. We know that if we look it up, there are 5,280 feet in 1 mile. Okay, in 1 mile. That's the downside of the system of measure we use. We have to know all these random, seemingly, they're not random, but they seem random values. Whereas with the metric system, you know, everything's a power of 10. You know, we multiply by 10, we divide by 10. It's real easy. That is 10 more than that. That is 10 of that. 10 divided by that, if you will. All right, but here, you know, we're going to keep the miles as they are. So we got 2 times. We need to convert this 6,000 feet into miles, and that's what we're going to do first. So we know, because we've looked it up, there are 5,280 feet in 1 mile. And your 155 instructors, depending on who they are, they may have given you a handout that has some of these, what we call conversion factors. Conversion factors. You hear that word factor, you should think multiply. You take one of this, multiply it by that conversion factor, you've converted 1 into that other unit, if you will. I digress. So we're going to do the same thing here. We're going to do the same process I showed you earlier. We're going to take the 6,000 feet, and we're going to make it a fraction. We're going to multiply it by, again, whatever our unit of measure is there goes here, mile goes there. And then we ask ourselves on the right side of the equation, which is larger, a mile or a foot? Well, of course, a mile is. And in 1 mile, how many feet do we have? Well, we now know there are 5,280. We multiply straight across, the feet are going to cancel out. We're left with 6,000 over 5,280. And we know fraction bar means divide. Okay, fraction bar means divide. It's always top divided by bottom. Okay, so if we do this math, we're converting these feet into miles. We'll simply go 6,000 divided by 5,280. Okay, and there's our solution. Okay, it's a rational number. It continues on, repeating pattern. You can't see that. All right, it's a repeating value. There's our solution. So it's 1.1363636. I'll just use all the values in the calculator. Your 120 instructor will tell you what your 120. Your 155 instructor will tell you what to round to. You'll be told how many values to round to. I'm using everything my little calculator will show on the screen because I know, and you should know as well, the more decimal values you use, the more accurate your answer will be, the better your answer will be, if you will. All right, so we've got that. Now we need to do inches. Well, inches, there's not a, we can look up any conversion. We can Google anything, and, we have to trust that the values that we're seeing on Google are correct. But there is no normal conversion. We just don't normally know how many inches are in a mile. It's just not commonly known. A common conversion from miles is feet. We know how many feet are in 1 mile, but we just don't walk around commonly going, oh yeah, there's 12,800. We don't know as a common practice how many inches there are in a mile. But we can use this process to find that answer. So let's do that. So we'll take our 6,000 inches. We'll make it a fraction. We're going to multiply it by something. Okay. Now here's the deal. We can't, as a rule, go from inches to miles. Well, we can go from inches to feet. So that's what we're going to do first. We're going to make this a two-step process. We're going to go from inches to feet, and once we get it in feet, basically we're going to repeat this process. Okay? So we're going to turn this into feet first. All right, so if we look at this one, which is larger, a foot or an inch, of course a foot is, and in 1 foot, how many inches there are? Well, there are 12. We multiply straight across, those are going to cancel out. We get 6,000 over 12. Okay, and if we do that math, let's see, 6,000 divided by 12, okay, there are 500 feet in 6,000 inches. So we've converted our 6,000 inches into feet. We haven't gotten into where we need to be yet, but now we have a conversion factor we can use because we know there's a common conversion between feet and miles. In 1 mile, there's 5,280 feet. So let's start this process over. So we got a new value here. We got 500 feet. Let's make it a fraction. Times something. Again, whatever our unit of measure is there goes here. So the thing we're trying to find always goes up top. Which is larger, a mile or a foot? Of course, a mile is. One goes with the larger unit. In 1 mile, how many feet? Well, we've looked that up. We know it's 5,280. So we're going to multiply straight across. The feet will cancel each other out, so we end up with 500 over 5,280. And again, top number divided by bottom. We do that math. We get 500 divided by 5,280. We come up with this value here. Okay, and it appears to be a rational number as well. It has a repeating pattern. 0.946969. I'm betting that 69 keeps repeating forever. So here we've got 0.09466969. Okay, let's just go ahead and multiply all that out. We'll go 2 times 1.1, because let me back up a second. We've now got a place where every one of these are in miles, the equivalent of miles. In 2 miles is obviously 2 miles. In 6,000 feet, there's 1.1363636 to eternity and beyond miles. In 6,000 inches, there's 0.09466969 miles. Okay, so we have them all in miles now, if you will. So we're going to multiply these together. So 2 times 1.1363636, whatever my calculator will hold, the more I put in, the better my answer, times 0.09466969. And that's what we get. It seemingly doesn't make sense, but it is what it is. Okay, because these have the effect, especially this one right here, of limiting that, if you will. So when we multiply all these together, we arrive at a solution. I've run out of page here. We arrive at a solution of 0.215. I'm writing at an angle to make it fit in. 52202. So that is our answer in numbers. But now we got to remember we converted this to miles. We converted that to miles. And then miles times miles times miles. We'll go ahead and put the answer down at the bottom. gives us 0.2152202 cubic miles. Cubic miles. Once you master this conversion process, if you don't already know it, this whole conversion process in general becomes so much simpler, so much simpler. So once you understand the process, take what you know, make it a fraction, multiply it by, something else. Whatever your unit of measure is here becomes your unit of measure here. The thing you're trying to find, the measure you're trying to convert to, is always your top value. There's going to be a 1. Sometimes it's up top, sometimes it's on the bottom. The question is, which is the larger unit of measure? Well, you put the 1 with the larger unit of measure, and then in that larger unit, you say, okay, in one of these, how many of those do I have? Okay, and that's a factor you may have to look up. You may have to Google it, maybe on a little cheat sheet that you're using, perhaps. But it does work. All right, moving on. I think we got 1 or 2 more of these. Multiply, and if conversion is needed, same old, same old, same old. So here, let's see, what units of measure do we have? We have a yard, we have a foot, we have a yard. Okay, so it's fairly simple here. Don't have a lot of conversion to do. Which is larger, a foot or a yard? Well, obviously a yard is. If you don't know, a yard is 3 feet. So we're going to take this value and we're going to convert it into yards. So let's just start out by going 77 feet, make it a fraction, times, again, whatever is here goes here. The thing we're trying to find goes up top. Which is larger, a yard or a foot? A yard is. 1 goes with the larger unit. How many in 1 yard? How many feet? There are 3 feet. Multiply straight across. Those will cancel out. We're left with 77 over 3. We know it's top number divided by bottom. So let's do that math. 77 divided by 3. So this becomes 25.6666 to eternity beyond yards. Okay, so now we've got everything converted into yards. The math is fairly straightforward. 40.1 times 25.6666 to eternity and beyond times 20.4 times yard times yard times yard. Okay, we do the math here. Let's let the calculator do the math for us. We'll go 40.1 times 25 point, I'll just fill up my calculator as many 6s as it will take, okay, times 20.4, and we arrive at that. Okay, so this gives us the numerical value. Multiply that times that times that. We get 20,996.359. And how many yards do we have? We have 3 of them. So we end up with a final solution here of 20,996 and 359 thousandths of a yard cubed, cubic yards. Okay. All right. All right. Here on these last couple, what we're going to be doing is basically just doing what it tells. We're in this first one, we're just multiplying the values together. We've got them in the same unit of measure. Everything here is in inches. We're just going to plug in all the values, and this would be this is our length. It's got them labeled for you, but I'll relabel them. And this is your height. This would be that rectangular solid, what we call a box. Okay, our length, our width, our height. Obviously, I didn't draw this to scale or even anything looking like a box, but that's what we've got here. And what we've got here is going to give us the volume, which is the inside of a 3-dimensional shape. What's the capacity for the inside? We call that the volume. Okay. And another way of looking at, we know this is going to be cubed. We got 3 inches. Another way of looking at why it's cubed is because of the areas of freedom of movement. If you have inside of a 3-dimensional shape, we can move side to side, if you will. We can move top to bottom inside this box, but now we can also move front to back. We've got 1, 2, 3 degrees of movement. We've got that's your cubic value as well. That's another way of explaining why the inside of three-dimensional shape has, well, three dimensions. Okay, so here we're just going to multiply. We're going to go 10.6 times 7.3 times 0.9, and then we have inches times inches times inches. Okay, this right here, the way I'm teaching this is probably the way most of you were taught it. You were taught to break it into the numerical part and the measurement value part, if you will, and do each separately and put them back together. A better explanation is why it's cubed is actually this right here. You've got those three dimensions of movement. You can move side to side, one dimension. You can move top to bottom, two dimensions. And in a three-dimensional shape, you can move backwards and forward three dimensions. That three dimensions relates to those cubic inches, if you will. So that's just two different ways to know, hey, if I've got three numbers, how many ways can I move in those shapes? Anyway, I digress. Giving you too much information, perhaps. 10.6 times 7.3 times 0.9. Okay, we have 69.642 or 69 and 642 thousandths. And we have inch times inch times inch, so we have inch cubed. Okay, so in this, maybe this box here that we've drawn, this rectangular solid, you call it Bob if you want to, doesn't matter what you call it. It has three dimensions, it has 3 degrees of freedom, if you will. We have 69 and 642 thousandths cubic inches. In other words, if we had a box that was 1 inch by 1 inch by 1 inch, 69 total ones would fit inside there, and then 642 thousandths of the remaining one would fit inside of there as well. Okay, almost 70 of them. Okay. Alrighty. Now let's get into some things we have to know a conversion factor for. Okay. Basically, we've got the problem here. We've got pi times radius squared. Pi times radius squared. Pi is a relationship, and your 155 instructor will talk about this perhaps. Perhaps you already know it. It's a relationship between the inside and the outside of a circle. It's a naturally occurring thing. If we take the circumference, which is the distance around the outside, if you will, it's the perimeter of a circle, and we divide it by the diameter, which is the distance across the middle, circumference divided by diameter is always going to give us pi. It's going to give us approximately 3.14, yada, yada, yada. Usually we just say 3.14. Okay, that's usually good enough, except in engineering and such subjects. We want to be more precise. That's what pi is. As pi is a relationship between the diameter and circumference of a circle. If you take any circle, 1 inch across, 73 million miles across, it doesn't matter how big it is. If you take a circle, you take the circumference, the distance around the outside, you divide it by the diameter, distance across the inside, you'll always get pi. It's a naturally occurring thing. We didn't invent, we discovered. But here we're being asked to do this. We're being asked to, everywhere we see R, insert that value. So let's do that. And for pi, again, normally with pi, and your 155 instructor may tell you a little different. They may want more values after it. Sometimes you'll see them use 22/7. I don't know if your 155 instructor will do that. 22/7 gives you a little bit more precise answer than simply 3.14. So you could interject either one of these values for pi, 22/7 or 3.14. We're going to use 3.14 for demonstration of how to solve this type of problem. So here we've got pi, so when we see pi, we put 3.14 times radius squared. Well, we're told the radius is 5.16. I'm going to put it in parentheses, and you'll see why. 5.65, I'm sorry. Okay, squared. And again, this becomes what I alluded to at the beginning of this presentation. This becomes order of operations. This is an order of operations problem because we've got multiplication and we've got exponents. You know, our order of operations, please excuse my dear Aunt Sally, tells us to do what's inside the grouping symbols first. But really this grouping symbol here is just simply, you know, segregating this part of the equation from that part of the equation. That's all it's doing. You know, we know there's no math to do inside of the parentheses. Okay, it's basically signifying that, oh, by the way, this is the value we're squaring. So that's what we're going to do. We're going to go 3.14 times, and this is shorthand for what? This is shorthand for 5.65 times 5.65. So let's do that. Okay, I've got a cheap little calculator here. So what was it? 5.65, 5.65 times 5.65. So we just squared it, and there's our answer. So 31.9225. So we did that part of the magic. We squared that number. We're left with multiplication, so we're going to multiply these two numbers. I'll just leave that one in the calculator because remember, the order we multiply in doesn't matter. You know, we go 6 times 5, we go 5 times 6, we still get 30. You know, multiplication is commutative. The order we do it in doesn't matter. Commutative means, well, it means that. Think about commuting. You know, when you go to work from home and you go from, you know, vice versa, you go the other order, the distance is the same. So the direction you're going in doesn't change the distance. That's a commutative process. So since I've already got this solution in the calculator, I'm just going to use commutative reality and just say times 3.14. And there's our answer. Okay, 100.23665. Okay, all right. And that is that. That is the answer. Okay, that is our solution. And that would simply be in centimeters. Units of measure is centimeters. This is not squared or cubed. This is just a measure of, if you will, distance. This is a measure of distance. Okay, all right. All right, seemingly getting a little more difficult, but they're not. They're not at all. The last one's going to blow your socks off, perhaps, but they're not. Remember, in math, you're never going to do more than one thing at a time. The trick is just to go ahead and know what one thing to do first, and then what one thing to do second, etc. Here, we're going to look at this scary-looking problem right here, which, if memory serves me, don't quote this, is how we get the volume of a sphere. A beach ball. You know, what's the capacity for the inside of a beach ball? Well, it's 4/3 times pi times radius cubed. I'm going to rewrite this because that 4/3 scares folks. I'm going to rewrite it like this. And oh, by the way, let's remember, we can make anything a fraction. So I can take that pi and make it a fraction. I can take that r cubed and make it a fraction. We can put anything over 1. So I'm going to rewrite this problem with fractions. I'm going to go 4 times pi times radius cubed over 3 times 1 times 1. I'm going to rewrite it that way. Okay? Fact is, I'm going to simplify it even more. I'm going to rewrite it again. I'm going to go 4 times pi times radius cubed. Well, 3 times 1 is 3 times 1 more is simply 3. So we can rewrite this whole equation here that looks scary into a very simplistic form. And by now, hopefully we recall that when we have a fraction bar, we're going to do the math on one side or the other, get solutions, and then we'll take top number divided by bottom. Well, the only side we have to do math on, common practice is do the math on top first, but does it really matter? No. We would simply do the math up here. We'll get a solution. We'll get a solution over here. We'll take top number divided by the bottom number. We're done. Okay? So we've taken something that perhaps is scary looking and made it into something more simplistic looking. Okay? So now let's plug values in. So we have 4, and again, where we see pi, we know that commonly we'll use 3.14. Okay? And then for radius, we're told to use 12.2, and we're going to cube it. Well, what does that cubing do? What does that cubing mean? Well, that cubing is telling us to take 12.2 times 12.2 times 12.2. Okay, so let's just do that on a cheap little calculator. You've got a good calculator. You can use the YX button. You may have a YX button, or some of them are XY buttons. Basically, put in any number, any power, and it gives you the value. So in this case, you'd put in 12.2 for either Y or X, and then you would for the exponent part, you would type in a 3, and it would give you the answer. Let's do it the old-fashioned way. 12.2 times 12.2 times 12. Oops, I hit the wrong button. 12.2, and we'll apologize for this guy outside my window again. Friday mornings, he's blowing off the sidewalk that has no grass on it, so we'll give him a chance to pass by. I'm absolutely certain he's paid by the hour. So he's blowing off the sidewalks. So anyway, 12.2 times 12.2 times 12.2. We do all this math right here. We get this number here. So I'm going to rewrite the problem using that value. So this is 4 times 3.14 times 1815.848. Okay, now remember, again, I told you in the previous problem, multiplication is commutative. So we don't have to clear this number, if you will. We don't have to clear that number from the calculator and then go 4 times 3.14 times that value. The order we multiply in doesn't change the solution. So I'm going to leave this number in the calculator, and I'm going to multiply from right to left. So times 3.14 equals times 4 equals. So that's the solution to the top of this problem. Okay, so the solution to the top of this problem is what's in the calculator. Okay, I'm just going to leave it there. I'm not even going to bother to write it down. Okay, I'm just going to leave it there on the calculator. Because now I've got a top answer here in the calculator. Here in the calculator, I've got the top answer. What does that fraction bar mean? It means divide, right? So we're going to take this top answer and we're going to divide it by 3. And there's our final answer. Our final answer to all of this, when we insert this value for radius, is 7602.35. Okay, and this is in what, feet? Okay. And this is neither squared nor cubed. Now this, I believe, is the formula for a sphere, so this actually would be cubic feet. But right now, at this point, all we care about is how we got that solution. Okay. All right. I'll leave this one up here for a second. Let you, as Uncle Jed tells us, let you ruminate on it for a little bit. Let you study on it for a little bit. This is powerful magic, if magic is the word. Okay, that 4/3 looks scary. Rewrite it this way. It looks less scary. And you can do that with any problem that has a leading fraction. The area of a triangle. The area of a triangle is, the area of a triangle. Area is the inside. Okay, is 1/2 base times height. Okay, the bottom times the height. You could rewrite this way. You could go 1 times base times height over 2, or even more simply, 1 times base times height is the same thing as base times height over 2. So you could rewrite this scary looking formula that way. Okay, any formula that has a leading fraction, you can rewrite it this way. Because you can make anything a fraction. Colors, shapes, Greek symbols, pi. Okay, you can write anything as a fraction. Knowing that reality, you can convert anything that has a leading fraction into a problem where the leading fraction goes away. It simply becomes part of the problem. Do the math up top, get an answer, divide by the bottom number. All right, last problem. Last problem is going to look very scary, but it is not. It's simply order of operations. Here we got this problem. It says, it doesn't say anything. It says pi times radius squared plus pi times radius squared times the square root of r squared plus h squared. Wow. Okay. So here in this case, we're given some values. We're told that where we see r, we're going to use 37.5 centimeters. And where we see h for height, we're going to use 45.9 centimeters. Okay, so let's do that. Let's just go ahead and rewrite the problem using these values every time we come across them. And again, for pi, common practice is we'll just use 3.14. Okay, 3.14 for pi. So let's just go ahead and rewrite this. All right, so I'm gonna give myself a lot of room. This is one of the ones I may have to pull out an extra sheet of paper because I want to walk you through every single step so you don't get lost. Okay, so first let's just rewrite it, inserting these values. So 3.14 times, let's see, radius is what? 37.5 squared plus 3.14 times radius, again, is 37.5. Okay, we're not squaring that one, we're just putting it in there. Times, okay, times the square root of this. Let's see, the radius is what? 37.5 plus the height. Oh, this is squared. That is squared there. Okay, plus the height is what? 45.9, and that is squared as well. Okay, so all we've done is we've inserted values where we see pi we've put 3.14. Okay, that's all we've done. We've put pi down for every one of those. Where we see radius, okay, we've inserted that value. We've inserted radius for that value. And lastly, where we saw height, which was just one place, where we saw height, we inserted that value. So that's all we've done. We've done substitution. We haven't done any math. We've simply inserted the values we were given into the equation we were given. Okay, that's all we've done. Now, what do we do first? We actually have some options, okay, but we're going to adhere to our order of operations. Order of operations, remember, please excuse my dear Aunt Sally. These are your grouping symbols. I won't write them all. Parentheses, brackets, curly braces, absolute value bars. This is exponent or our radicals. We obviously know that's multiplication, that's division, that's addition, that's subtraction. We do those two together, left to right, same as with adding and subtracting. So if we have a problem and it has division before multiplication, we'll do the division first, working left to right. If we have a problem and it has adding and subtracting comes first, we'll do subtracting first, left to right. We treat multiplication and division as the same thing, mirror images of each other, same with adding and subtracting. So here becomes the question, do we have any grouping symbols? Well, yes, we do. But what have we done with these grouping symbols? We've really just segregated the values from the the square symbol, the exponential value, if you will. So the reality is, we've got choices. But the reality is here, you can choose, and it doesn't matter. It's really your preference. You can choose just to do everything under the root bar, the radical symbol first. Okay, or you can simply choose to do your exponents first. We'll just work it left to right because that's good practice. So we'll go 3.14 times, well, let's square that number. That's what that means. So 37.5 times 37.5. Okay, and this right here becomes 1,406 and 2,500ths plus, okay, let's just go ahead and work it left to right. Plus, let's just go ahead and multiply that. This one's not squared. This one right here is not squared, so it's just one time. So 3.14 times 37.5. And when we do that math, we come up with that. 117.75. Okay? So we did this math, we came up with that. We did this math here, we came up with that. Okay, so that's where we are. That's where we are now. Now, let's come over here and work on this part. All right. So we're going to do the math under our radical symbol first. Okay. So we're going to get an answer for all of this, and then we'll do, because that little divot there, if you will, in our root bar right here, that little divot's called the index. And if there is no number in there, it means square root. Okay, so we're going to do the math here, get a number, and then do the square root of that number. And then we'll finish up the rest of the math. All right, so let's just go 37.5 squared. Well, we already did that. We know the answer's right here. There's the answer. So we're not going to, reinvent the wheel, if you will. 37.5 squared here is going to be the same thing as 37.5 squared there. So we'll just go ahead and insert the value. We've already got it. If you already have the solution, just use it. Here we don't have that one, but we'll use it, so we'll do the math. So we've got 45.9 times 45.9. So this becomes 2,106.81. All right, so where are we? Well, we're to the point where this has become that has become that. We still have addition, so we'll do that. So let's just rewrite the rest of this. So 3.14 times 1406.25 plus 117.75 times the square root of that. They're right next to each other, so it means times. There's no space there. So let's add these numbers. And addition is commutative as well. Remember, the order we add in doesn't matter. 5 plus 2, 2 plus 5. So I could clear what's out in the calculator for this solution here and then simply type both of these numbers in left to right. Or I can simply leave this value in the calculator and then just add the number to the left. So plus 1406.25. And this is what we come up with for under our radical. 3513.06. Okay? All right, so we got that. We'll leave that in the calculator. Let's just go ahead and rewrite the problem again. 3.14 times 1406.25 plus 117.75, okay, times, we'll go ahead and put a time symbol in there, the square root of that number. Okay, so on my calculator, I have a radical symbol right here on this little cheap $2 calculator. Once I have it in, and this is one thing your 155 instructors may address, because each calculator does this differently. If you have one of these, these fancy little graphing calculators, if you will, you're going to put in the radical symbol first, and then you're going to put some numbers in it, and then you hit enter. Okay, with this little calculator here, and again, yours will vary. Okay, I simply hit that button there. So basically, it's told me if I multiply this number times itself, I've taken this square number back to its root. Listen to that language, square root. I've taken this squared number back to its root. Okay, back to its root. Where, what am I talking about? Well, the square of 100 is 10. I've taken it back to its roots, and then if I square that number, I get back to it. They're kind of mirror images. Adding and subtracting are opposites. Multiplication and division are opposites. Exponents and roots are opposites. Okay, so I've taken this squared number back to its roots. So I squared this number. We did the root of this number, and we came up with this value, 59 point, and we'll just use all the numbers that are on my calculator, 71072. Remember, the general rounding rule, we don't use that language enough, but the general rounding rule is you do not round off until you get the final solution. That ensures you get a better solution. There are answers, and then there are better answers, especially when decimals are involved. As a rule, the more decimals, the better the answer. We toss around terms like precision and accuracy in mathematics, and those terms are important, but at the simplistic level, it simply means the more numbers you have, the better your answer. Okay, the better your answer. We'll keep it real simple. All right, so what do we got now? So we got a situation where everything has been cleared up. Okay, so now we've got the operation of multiplication, we have the operation of adding, we have the operation of multiplication. Well, old Aunt Sally over here, she tells us we're going to do all of our multiplication and division before we do any of our adding and subtracting. So if you will, doing it left to right, there's step 1, there's step 2, there's step 3. Those are our dance steps. We haven't talked about dance steps in a while. So let's just go ahead and do the math left to right. So we'll go 3.14 times 1406.25. We do that. We get this solution here. I know you can't see it, but I'm running out of room, so I have to slide the calculator so I can see it and you can see it. So we do this math here, and we come up with 4415.625 plus, let's do this math over here. All right, so we're going to go 117.75 times 59.271.072. And we do that, we get that solution. So we're going to write that solution down. So 6979.1687. Let me double check that one, just for laughs and giggles. So 117.75 times 59.271.072. 6979. Yep, okay, I thought I hit the wrong number for some reason. So we've done this math, we arrived at that solution. And the last bit of paper I have remaining here, we're simply going to add these two together. Again, remember, addition, just like multiplication, is commutative. The order we do it in doesn't matter. 5 plus 2, 2 plus 5, you get the same answer. I already have this number in the calculator. Okay, I'm just going to leave it there and then add that number to the left to it. So plus 4415.625. Our final solution to this hot mess is 11,394.793. What was all this in? It didn't give us. This is just a length value. Okay, so there's our final solution. A lot of stuff, if you will. Okay, when you have problems like this, okay, first thing you're going to do, you're going to take the values you're given, you're going to plug them in. Okay, and then you're going to realize you have several different operations. You have multiplication, you have exponents, you have radicals, you have addition. You have a lot of stuff, being the technical term, going on. So you've got to fall back on dear old Aunt Sally. Please excuse my dear Aunt Sally. Okay, realizing that, yeah, we do have grouping symbols here, but we've really only used these grouping symbols. We've artificially created them, if you will. They weren't there originally. We artificially created them to segment one part of the problem from the other. So there's really no math to do in these. So then we fall back on what? We fall back on exponent, which is basically the ease. It's do your exponents and or your roots. We could have done the roots first. We could have done the radical first. It wouldn't matter, but I just followed standard practice working left to right. Then once we cleared all that up, all we had left was, multiplication, addition, multiplication. Of course, we're going to do multiplication and or division. All of those, we're going to clear those up before we do any adding and subtracting. Okay. All right, folks, that's it. Thanks.